In this video, I'm going to show you how you can use Composabl to create AI agents for industrial processes without using any code. And instead of using code, what you do is you teach your agents by bringing your subject matter expertise and engineering knowledge about the process to define what the agent needs to learn. Composabl then takes that information and converts it to deep reinforcement learning rewards functions that allow the agents to train in simulation, get better and better until they can perform the task. And if you do this a few times with different parts of your process, then you'll end up with a team of agents that you can orchestrate together to produce results that optimize your process, improve performance, and create AI that's modular, explainable, efficient, and beats benchmarks. So here we're in the agent orchestration studio, and I'm going to show you how to create a new skill agent and teach it by setting the configuration with different information about the process. So I'm going to click on plus here by skill agents, and it's going to take me to the skill agent page. And now I'm going to add a new skill agent. We call these skill agents because these are agents that perform the kinds of skills that a human might need to perform, just like an operator. And they learn to gain skill and become skilled, just like humans do. So the agent that I'm going to show you how to create is for a chemical production process. And what we're trying to do is to maximize the yield to make as much of this chemical product as we can. So I'm going to call this skill agent maximize yield. You can see that I already have a skill agent with the same name here on the left, but that's fine. I'm just going to do this for the demo purposes. So I click on that button, and now you can see the configuration options. This skill is a teacher. That's the implementation method. The other option would be controller, and that would be a programmed skill that you'd create in Python and publish to your project so that you can use it in your multi-agent systems. But in this case, we're using a teacher, so we're giving it the information, and then it's going to learn in deep reinforcement learning in simulation by practicing and be trained within the Composabl platform. So what we're going to do to teach our agent is we're going to set goals and constraints. So we start with adding a goal. And you can see that we've got three different goal objectives, three options for our goal. If we use maintain, that's something you can use to track a set point, to maintain a relationship with a value or a variable. But in our case, we're going to, we could also minimize, but in this case, we're going to maximize. And you already know that we're going to maximize yield. And the variable here, and these variables come from the simulation. So these are part of the process as it's defined in the simulation. The variable we're going to choose is this EPS yield. And EPS means that this is the yield at the end of the episode, because that's what we want. When the entire reaction is finished, we want to maximize the amount of total product that we get at the end of this. So you can add multiple goals if you want. Usually, not more than a couple is all you'll need. And in this case, we're just using the one. But we are going to add some constraints. Constraints are like the rules of the game. These are the things that they're not the goals. It's not what you're trying to optimize. But if you don't do this, or if you do something you shouldn't, or you don't do something you should, then you've broken the rules and your agent is not successful. So in this case, what we're going to use constraints for is to manage the temperature in the tank where this chemical reaction is happening. So this is a reaction that heats up as it proceeds, and it's supposed to heat up. It needs to heat up in order to get the most yield. But if it heats up too much, then a process called thermal runaway can occur, at which the tank can explode. So we definitely need to avoid that. We've got two different types of constraints, and we're going to use both of them to make sure that we're really covered with this safety concern. So avoid is where you are able to tell when your agent is training, if it gets into this space that it's not supposed to be in, it'll withhold reward. It will get less deep reinforcement learning reward, and that'll teach it not to do this. So T is our variable, that's temperature. And if T is between, we're going to set this as 390 degrees Kelvin to 399. This is 390 to 399 is the range where if our agent gets into that range, then it's going to start getting less reward. And so it's going to need to try to get out of that range. But we need another constraint because 400 degrees is the threshold where thermal runaway can occur. And at 400 degrees, we don't want to just withhold reward. We want the agent to understand and learn that crossing that line is not just something to avoid, but something to never, ever do. So here we set the terminate condition. Terminate if it goes anywhere over 400. It's going to stop the agent training and start a new episode. And basically that's giving the agent a message that you failed, it's over, learn your lesson, don't do that again. And putting these together allow you to give a sophisticated, nuanced way for the agent to learn to avoid this condition while also maximizing the yield. Success criteria we're not going to use. Success criteria is basically the opposite of the terminate condition, where you can tell the agent that it succeeded and the episode is over. And you might use that for something like if you're landing a rocket, then when the rocket's on the ground, then you succeeded and you don't need to continue the training anymore. You can, go back to the beginning and try to do it again. But in this chemical process, it goes on for a certain amount of time. That's when it ends, not when it hits success criteria. So we're going to save the configuration. You can see that it updates. Now we have a V1, version 1 of the skill. We can go back to the Agent Orchestration Studio, and here it is. And we can use it to orchestrate it in to our multi-agent systems and start to use it in our designs. So thanks for watching, and I look forward to see what you will build.